Okay, there seems to be a little bit of confusion about how to do your table and graph. So I thought I'd do this little video for you real quick just to hopefully clear it up. So this is the worksheet where you're going to try to put down the orbital notation for the particular kind of ions and the salts that we worked with. I sort of transferred part of that up here on the board for you. I'm just going to go through the first one of these for you, manganese 2+. That is capital M, little n, 2+. And we're going to fill in all these blanks for you and talk about how you go about putting that into your worksheet and then how you're going to put that into your table and graph. So manganese, if you look on your periodic table, is in the 1, 2, 3, 4th row, and it's 1, 2, 3, 4, 5, 6, 7 elements over, and about halfway over into the transition metal. So we're going to have 1 electron, then 2 electrons. That fills up 4s, and then 3, 4, 5, and 6, and 7. So that's manganese element. That's the atom before you have the 2+ charge on there. I'm going to go ahead and fill this one in because we're going to need to do that in just a minute. Now what you're going to do on this sheet is you're going to do this twice. One on this side of the sheet and one on this side of the sheet. But the difference is that on one side of the sheet you're going to remove electrons to make ions in one way, and on the other side you're going to remove it in a different way. And that's why I have it twice up here to show you how to remove electrons in 2 different ways. We went over it in class, but seems to be some confusion, so let's try to clear that up for you. All right, so one way to remove electrons, if we're trying to create an ion, we have a 2+ charge, and these arrows all represent electrons. Electrons are negative, so if we remove negative electrons, we create positive charges. If I have a 2+ charge, I need to remove 2 electrons. So the first way we could remove electrons is to take them off in the way we put them on. We put them on 1, 2 here, and then 1 in each of these boxes. So if I take them off in the same order I put them on, I'll be taking off this electron and this electron. So this orbital notation is what you should put on one of the 2 sides of your worksheet. Okay, so here you put 2 electrons, and in these other 3 boxes here you have 3 electrons. All right, so this will have 3 unpaired electrons. These electrons are paired. They're in the same orbital. They're 1 up, 1 down, the way we were writing orbital notation last week. And so these are the only unpaired electrons. So the number of unpaired electrons for this arrangement is 3. And the mass that you're going to put in the next column, so your number of electrons goes in this column, the mass is going to go in this column, is whatever you measured when you put your sample of those salts over those magnets on the balance. And I don't know what that's going to be. So you have to put in that number here. Okay? Should have been a negative number. I ask you to be very careful about watching the change of sign and being sure that you did that. Okay? So that's one way to remove electrons. Another way to remove electrons that we talked about in class is to start with the highest energy level first. Well, this is 4s, and this is 3. So the highest energy level is 4. So if we start with the highest energy level, I can remove both electrons from 4s, leaving me with 1 electron in each of the 3 d orbitals. So that gives me a 2+ charge because I removed 2 electrons. So on whichever is the other side of the sheet you're working with now, the second, on one side you're going to do this arrangement, on the other side you're going to do this arrangement. So here I'll put a blank, I'll leave this box blank here and put 1 electron in each of these boxes. And now the number of unpaired electrons I'm going to have on this side of the sheet is not 3, but 1, 2, 3, 4, 5. 5. And again, the mass won't change. The mass is the mass that you got when you were in the lab. So after you fill out both sides of that sheet, then you're ready to do your table and graph. And on your table, all you have to worry about is the number of unpaired electrons from the first sheet and the mass. So you really only need 2 columns. If you want to do start a column that has the actual identity of those ions in the first column, manganese 2+, iron 2+, you can put that in the first column if you want to. And the second column will be the number of unpaired electrons that you have for the arrangement you're working with. So if you're working on the front side of the sheet, it'll be 1 type number maybe, and on the other side it'll be a different number. So the number of unpaired electrons will depend on which side of this original sheet you're using to bring your data from. The second column you're going to have, or the third if you list the ions in the first column, you're going to have a column of unpaired electrons, and over here you're going to have the change in mass. Change in mass is not going to be different. It's going to be the same for both sets of data, for both tables, and then both graphs. So the other side of the page, you've got some graph paper, and you're going to graph those results. And you want to have the number of unpaired electrons is what you changed. When you changed the, in the lab back here, when you changed the salt that you were testing on those balances, you were, by doing that, changing the number of unpaired electrons. So you want that to be your independent variable. The dependent variable, the one that where there was a resulting change because of what you changed, that would be the mass registered on the balance. So wherever you decide your independent variable is going to be, that needs to be where you put the number of unpaired electrons, and the change in mass is going to be on your y-axis. That's your dependent variable. Independent variable is always on x. Dependent variable is always on y. And then if you want to look on the website, there's also a PowerPoint that I have on there that will go through all those steps that you're supposed to have for a formal table and graph. Okay, so you've got two of these sheets with graph paper, so you're going to do two different tables. One table will be for removing electrons in one manner, and the other table is for removing electrons in the other manner. So that column of data, number of unpaired electrons, is going to be different in the two graphs, but the mass change for both graphs and both tables will be exactly the same. I hope this helps you to clear it up. Feel free to email me if you have any more questions.